Modern sensor circuits depend on power supply, signal, and ground, working together as a system. If any leg fails, your measurements or scan data can point you off course. Let's learn to prove each path and avoid misleading clues. A typical sensor has a power supply, a ground, and a signal wire. The ECU provides a regulated reference voltage, monitors the signal, and relies on a low-resistance ground path. Any high resistance, short, or open in these paths creates misleading codes, odd sensor data, or performance issues. The ECU judges sensor readings by checking if the signal value matches expected operating conditions and comparing them against related sensors. It can set plausibility or rationality codes if supply, signal, or ground faults create readings that disagree with the rest of the system, even if voltages are in range but implausible. Scan data reports what the module interprets, not always the real voltage at the sensor. For instance, a bad ground may cause several sensor readings to shift together, fooling the scan tool. Always verify live data by comparing multiple PIDs and confirming with direct measurement at the sensor and ECU pins. Measure the voltage at the sensor supply and ground under key on and load. Check for expected 5-volt supply, minimal ground voltage drop, and plausible signal output with the circuit loaded. Move your meter leads to the ECU pin and compare values. Finding a voltage drop or difference tells you exactly which circuit branch has resistance or a break. No single reading gives the whole picture. The correct practice is comparing scan tool values with direct measurements and considering what the system should read under these conditions. If you measure a full 5-volt supply, but the scan shows low data, or multiple sensors share an odd value, you'll know the issue is in the ground or signal branch. Never replace a sensor just because of a code or one strange reading. Sensors, connectors, wiring, supply voltages, and grounds all affect the circuit. Prove where voltage, continuity, or load fails. Don't let a misleading scan value waste your time and money. Start with the code and symptom. Use your scan tool to review live data and related PIDs. Next, confirm reference voltage and ground with your meter, both under load and at the ECU. Compare values at each connector to isolate faults, and use plausible-unplausible reading logic to spot hidden supply or ground errors. Sensor circuits are 3-part systems. Diagnosing only supply, ground, or signal in isolation leads to trapdoors and wasted time. Always test, compare, and prove each leg to quickly find and fix the real cause. In every diagnostic, remember, scan data, direct measurement, and circuit logic must work together to reveal supply, signal, or ground faults. Keep testing, not guessing, for reliable repairs.